My name is Justin Sotomayor. This is Group 1's project on the effects of caffeine on the 1 mile Rockport walk test. Our project is on the impact of caffeine on the time it takes to complete the Rockport 1 mile test. We use 3 milligrams per kilogram of body weight of caffeine as our dependent variable on this test. The independent variable is the 1 mile walk test, as they will take it with caffeine and without caffeine happening before, to compare their times if it does increase after consuming caffeine. Well, 9 subjects performed the 1 mile Rockport test without caffeine, and again, 30 minutes after consuming 3 milligrams per kilogram of body weight of caffeine to compare their times and see that if the consumption of caffeine helped with that 1 mile walk test and they had a lower time after consuming caffeine. For our relevant research, coffee's excitatory activity at the supraspinal level may produce enhanced motor unit recruitment at rate coding of larger lower body muscle groups such as the quads, glutes, hamstrings, a lot of the muscles that help move our body faster, and a lot of athletes or average people rely on to increase strength and explosion, which would account for the increases in performance following caffeine ingestion. Through its effects on adenosine receptors, caffeine also lessens the perception of discomfort during exercise, helping lessen the idea of fatigue or discomfort or any pain that they may feel in the muscles by helping the blood flow and then decrease the perception of any discomfort in those areas, which may lead to an increase in maximal voluntary contractile force. Consequently, there remains a substantial likelihood that caffeine actually acts as an adenosine antagonist and impairs leaping performance when shown on a study on the caffeine's effect on jumping ability. Additionally, it has been shown that caffeine increases reaction times, logical thinking, and attentiveness, all of which may improve performance in lab work and athletics, which is why caffeine is seen often in things like pre-workout, or athletes are often consuming things like coffee or caffeine pills before they go and start their competition or just their exercise in general. Gaps in literature, there's no systematic review that have looked at the effects of caffeine on performance in the past for either sex, seeing that if either sex has different reactions or different results to caffeine. The primary limitations were needed to further data, and sometimes small sample sizes are used in research, so there isn't enough on a large scale to see the effects of caffeine. Few studies have been conducted on the effects of caffeine on anaerobic exercise, and even fewer have looked at how the drug affects anaerobic performance in more specialized sports. The ones we looked at, there was one for jumping ability that was touched on in the previous slide, and then there was also on biking ability and cycling. Furthermore, studies are needed to look at how aging affects the effects of caffeine during exercise, that if younger people are more susceptible or more reactive to caffeine, or older people are less reactive or more reactive, and seeing the effects in that way. And then taking into account the metabolism and resistance to caffeine, that if someone drinks caffeine on a very regular basis, they may need more caffeine to get the same results as someone that never drinks caffeine gets with the prescribed amount. The research aimed to compare the effects of the 3 milligrams per kilogram of body weight of caffeine on the 1 mile Rockport test. The purpose is to see if caffeine can improve road performance and improve results by lowering their time of the walk test. The hypothesis is that caffeine consumption will improve performance, shown by a faster time on the Rockport 1 mile test.